So I welcome you to my new video. Today's question is binary search. So it is an important topic in our DSA course. So given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with big of log n runtime complexity. We will see how it is coming. Let's take an example nums array, which is -1 0 3 -1 0 3 5 9 12 5 9 12. We have to search our target, which is 9. Target is 9. So binary search always apply on a sorted array. Why? Suppose let's take an example of a dictionary. You have to search a word starting with S. So you will try to open we try to open dictionary from mid. We do not search line by line like page. We open dictionary from the mid. Then we see that on left page the words starting are from less than S or greater than S. Like we see like this. If it is greater than S, we search on the left part. If it is less than S, then we search on the right part. And if it is equal to S, then we search on that page. This is how dictionary works. Our word meaning dictionary. So here the concept is like this only. We try to reduce the search space by eliminating up left part or right part. Suppose we have to search 9. So let's keep 2 pointer here first, high or low. What is the mid? Mid is simply low plus high by 2. It is mid index actually, mid index. See the indexing 3 4 5. So it is 5 plus 0 by 2, which is 2. We'll take integer 2.5, we will say 2. Now see the element at the mid index, which is 3. 9 will be greater than 3. 9 is greater than 3, so we have to find 9. So we will eliminate the left part, not right part. So low pointer will move here. Now 9 will lie here only because it is greater than 3. It will not lie less than 3 because it is sorted. So we will eliminate the left part. So we are decrementing the searching space. So we are saving our time. We will calculate time complexity also at the end. But let's now see how it is working. So now our new low and high are this. So new mid is 5 plus 3 by 2, which is 4. This now we found at this then we found the answer, target at mid. We found our target at mid. So we return this index, we return 4. So this is how it is working. Let's code this. So we will take index equals to answer equals to -1. Initialize it with -1. Then we will keep a while low pointer and high pointer. Int low equals to 0 and int high equals to nums dot size -1. Till when it will work? Low should be less than high, less than equal to high. Otherwise we will return -1. When low is less than equal to high, then we will have to calculate mid. Int mid equals to low plus high by 2. Now what we have to check? We have to check if nums of mid is equal to, if we find the target at the mid, then we will return mid index. If we will not found, then if if nums of mid is less than target, then what we have to do? We have to decrement high pointer or left pointer. Suppose 3 is less than 9, so we have to trim the left search space So we'll increase the left pointer to mid plus 1, low pointer to mid plus 1. Else if it is greater than, we will decrease the high pointer to mid minus 1, and similarly we will return answer. And at here we will actually return mid, and else we will return answer. Okay, it is right, I think. It is easy, that's why it is submitted. Otherwise it there is one edge case of overflow happens if your suppose array is this containing int max number, containing many numbers. So if your index like this, suppose your mid is low plus high by 2. Now suppose a low becomes int max, low is here also and just here, and high is also here, minus 1, int max minus 1, a very large number, you can imagine 10 power 9, 10 power 9 minus 1. If we will add this, it will be overflow. We cannot store it in data type. We have to take long, or we can do one mathematics also, like low plus high minus low by 2. It is same like this, because 2 low plus high minus low by 2. Low, say low will cut 1 low, and we will left with low plus high by 2. Okay, so we can add this method also to prevent overflow condition, edge case. So it is low plus high minus low. Let's submit this. We submitted. Now see what is the time complexity of this. So first of all, mid is 0 plus 7 by 2 is 3. Then we will see 4 is greater than or less than 1 minus 1. It is greater than minus 1. So we'll trim this part, and our high pointer will move to mid minus 1. Low is here. Now new mid is 2 by 2. 2 plus 0 is 2 by 2, which is here. Now mid is here. Low is here. High is here. Now see 2 is greater than, so our high will come here. Now mid is also here. We will see, compare the 1 and minus 1. It is still greater. So high will reduce to here, and value will break because the condition of low is less than high becomes false. Now see how many steps. First of all, searching space was 8. Then it reduces to 3. Mid was here, then 3, then high was here 1, 3 steps approximately, and 8 is also 2 to the power 3, 2 to the power 3. So if we will take, so that means it is log n, log of 8, which is equal to log of 8. Answer 3 is equal to log of 8, log base 2 of 8. This means our time complexity becomes big of log n, log base 2n, because n is the size of the array. So this is how the time complexity is calculated. Now let's move to a recursive solution of this. We have seen the solution to iterative solution. Now we will see the recursive solution of this. So if you know the basic recursive, we have to repeat one steps. We have to repeat some steps which are in the while loop. See, we are repeating these steps, calculating mid, then comparing. Okay, so what we can do is, we can do a recursive solution like this. This is an array, minus 1, 0, 3, 5, 0, 3, 5, 9, 12. What we can do is, target is 9. So what we can do, 0, 1, 2, 3, 4, 5. we have to do recursive solution. So we have to repeat. Recursive means calling the function again and again. Let's make the function and pass low, mid, and high here. And yes, and target also. Target in the function. Now see, what it will do is, if we'll calculate the mid, and first of all we'll pass the mid as, mid is low plus high by 2. If nums of mid is equal to target, then we will return mid. Simple. I think we do not need to pass mid here. We just need to pass low and high. Else if when nums of mid is less than target, what will happen? What we have to return? We will return, we have to trim the right space or left space. Think we have to, because it is less than target, so that's why we would not search in the left part, so we will trim the left part. So we will increase the low to mid plus 1, and I will remain high only, target, and we will return this, pass it as a function because it is recursion. Now see, else we will return. Now we have to trim the right part, so it is function of low will be low, high will be mid minus 1, and target is target only. First of all, let's code this, then we will see how it is working. Let's code this recursive solution. We have got this search, nums target. We will also make a binary search, b search, f function here. We will pass vector nums target also here, and we will pass low and high also, low, high. And what we have to calculate? We have to calculate one more thing, which is answer. We can keep answer in the function also, or we can return it from here, and we'll call a function here over here. So return, answer equals to function, and we'll pass nums target or and it will pass low is first of all this, high is nums dot size minus 1, and just we need to pass this. Suppose we do not find any answer. If we do not find any answer, there will be one more condition of if low is actually if low is less than equal to high, then only it should work. then only this should work, else we will return -1. Okay, so this was the case. So what I will do, I will just write return here, and we will remove here, remove this, and remove this. Now what we'll do, we'll just calculate mid, or we'll put an if condition. If low is less than or equal to high, else we will return -1. What we will do, we will just calculate mid first. Mid equals to what I taught you, low plus high minus low by 2. Then check nums of mid is equal to target. Then we will return mid, else if we will check if nums of mid is less than target, then we will reduce the left search space. We'll do it mid +1, comma high, comma. Actually, first of all, nums will be passed here also, target also here, target, else return f nums target low mid -1, high will be reduced, right search space will be reduced. I think it should be correct. Let's run this. Int low, actually int low, int high. I think it is running correctly. Sheet is submitted. Now let's see how the recursive solution is working. Let's dry run this. Let's dry run on this test case. You will enjoy, I think. Make a copy of this. We will paste it here also. Duplicate this image again. See, you will enjoy the dry run. Now see, what will be passed in the function? First of all, low is this, high is this. So what is passed? 0, and target is 9. So 9, 0, 12. This is 0, 1, 2, 3, 4, 5. So what will be passed? Now let's do the dry run. Rub this. Again, we will do the dry run. So I hope you are seeing this. So target is 9, int is 0, low is 0, and high is initially 5. We will pass this in the function. Now check what is the mid. 0 plus 5 is it will come 0 plus 5 by 2 is 2. So mid is 2. So nums of 2 is nums of 2 is 3. 3 is equal to target. No, it is less than target. Yes, if it is less than target, let's call a function with value nums target is 9 still. Mid plus 1 is 2 plus 1, which is 3, and high is 5. So what will be passed? 3, 5, 9. Now what is the mid? 3 plus 5, 8, by 4, by 2 is 4, and see, what is 4? It is 9. It is 9. We are seeing it is 9. So it is equal to 9. It is equal to the target. Yes. Then return 4. We have returned the 4. So let's return this to this. Now this function will return 4. This function will return 4 from where we have called this. So we will return in the main the 4. This is the answer. I hope you like the dry run. So we will meet in the next video. Till then, goodbye.